Good morning, good afternoon, good evening to wherever you are in the world. We're delighted to have you joining our webinar today on the demand-driven operating model and visibility to system flow. My name is Erik Bush. I'm the CEO of Demand-Driven Technologies and pleased to be your host for today's webinar. Before we begin, a couple basics on webinar settings and the like. First of all, for purposes of audio quality, we keep everyone on listen-only mode. And that enables everyone to hear the broadcast clearly. Doesn't mean, though, that we're not interested in your questions. If you look at your webinar control panel, you'll see a question feature that you can utilize to ask questions during the presentations of the webinar. And then at the end of the session, we'll use that time to go back over the questions that have been submitted, get Debra's and Kirk's responses, and ensure that we get those covered off before we conclude the session. Secondly, the webinar is being recorded, and this will allow us to send you a link later today, which will have the webinar recording that you can use for future reference. You can also share that link with others on your team that may be interested in reviewing the content of today's presentation. Finally, we will be sending out a follow-up email with presentation content for your review as well. So we'll be getting all of that material out later today for your reference, and hopefully that'll enable you to continue to learn more about demand-driven operating model and the concepts that'll be presented by Debra and Kirk today. So without further ado, I'm going to introduce Debra Smith. She is a true world-class thought leader in the demand-driven movement, has been an author of several books, has led the most sophisticated and impressive demand-driven operating model implementations with her clients around the world. So we're delighted to have her contributing to this series on the DDOM. Along with Debra today will be Kirk Black of the Constraints Management Group, one of the members of Deb's team, who will be doing the demonstration for DBR+. So without further ado, I'll pass it over to Debra.
Good morning, and thank you, Erik, for the introduction. It's good to be here. Kirk is joining us today from Bogota, Colombia, and I'm joining you from Seattle. Today is the second deep dive into what we're calling the DDOM series, and it's visibility to system flow, the key to keep your market signals and actions aligned. The agenda today is we're going to do a very short summary of Webinar 1. If you haven't seen Webinar 1, then I strongly suggest you see it before viewing this, because it lays a foundation and you're going to be confused, and I don't have the time in 1 hour to put everything together. We're going to talk about the demand-driven adaptive enterprise, do a deep dive, and show you where DDOM fits inside that. We're going to look at what we talked about last week and how it fits in the demand-driven adaptive enterprise. And we're also going to look at what are we going to be talking about at the next webinar. We're going to emphasize the right rules, because using the wrong rules to manage systems today is the core of the problem that we're trying to solve. We're also going to talk about thoughtware before software and what are the role of both of them. And then we're going to spend time deep diving into the demand-driven operating model and the DDMRP criteria. Just a very brief overview. If you don't know it or understand it, I suggest you go out to the Demand-Driven Institute website. They are the people who are the experts in what's the minimum criteria you need to be demand-driven, and they're setting the standards globally. We're going to spend our time looking at what does it take to be a demand-driven scheduling and execution, and what's the criteria that DDI says is the minimum for you to be effective. And the last thing we're going to do today is give you a DBR Plus software demo. I'm not going to spend any time here. I did in the first webinar. The whole point of showing you this is this has been a very long journey. We have blended theory of constraints, drum buffer rope, lean, Six Sigma, and a very solid dose of management accounting and basic economics with factory physics to come up with what it is we call demand-driven today. The whole point of these slides is for you to see the results. I want to be very clear. These results have been touted as demand-driven, but they are demand-driven operating models. None of these companies have DDMRP only. You only get these kinds of results when you combine DDMRP with demand-driven scheduling and execution and smart metrics. That's what drives continuous improvement and focus, synchronizing your entire supply chain. we're going to, in the first webinar, we had a case study from Corona. In the next webinar, we're going to be using stem cell and amoeba as examples of tactical reconciliation and how they're driving their focused improvement and keeping their demand-driven operating model current and sustainable. I'm not going to spend any time on CMG. It's here. You can look at it. But I want to deep dive into the problem. I have a problem statement that really talks about why we can't get to flow. And the point here is that companies lack an effective organizational model. You have to have visible metrics and a visible communication system that is real-time as you need, that enables a company to sustain and evolve a flow-based operating model. It's because companies today exist as a complex enterprise. If you are a simple enterprise, then you may not need all of these components. And when I say simple, you have 2 products and you have dedicated lines, and you have a lot of sprint capacity. If that describes your world, then you may not need a demand-driven operating model. You may get by just fine, but I don't know any companies that fit that mold. Demand-driven is really going for 4 effects, and we talked about 3 of them in the last webinar. The reason we focused on 3 in the last webinar is because we were setting up the demand-driven operating model from a standpoint of what is blocking flow. And everybody understands that MRP forecast distortion, which is handled by DDMRP and R+, is a major source. We also spent a lot of time talking about the cost-flow conflict and why smart metrics are necessary in a DDOM. The outcome of a DDOM is smart metrics. But we didn't spend any time talking about ending supply continuity variation. Supply continuity variation is really describing schedule nervousness. What happens when we put a non-realistic schedule, a schedule that we can't possibly meet, into our operations? What DBR Plus is doing is solving that. That's the role of drone buffer rope. When all of these sources of variation go down, then we have the ability to align tactics. So today we're going to be talking about DBR Plus and supply continuity variation. What's the source of it? How do we solve it? And our next webinar, we're going to be dealing with smart metrics and aligning strategy, tactics, and execution around system flow. So let's get started. The major source of supply continuity variation is schedule nervousness. And where does schedule nervousness come from? It comes from the way our ERP systems schedule today. Advanced planning optimization follows system rules that are linear. In order to deal with and managing our environment today, we have to follow and assume that there is going to be variation in the environment. In order to solve the problem of supply continuity variation, you have to identify the source, and the major source is schedule nervousness. Today's advanced planning scheduling systems follow linear rules, and that doesn't work for complex adaptive systems. They fail to recognize and account for supply continuity variability, Murphy. Murphy's alive and well and exists in every manufacturing operation I've ever been in. Their only response to variation is to reschedule and expedite, and that's done on a continuous basis. The more often you reschedule and expedite the floor, the more variation you add to the environment. When you look at complex adaptive system rules, they're very specific. They follow Paretian statistical models that we talked about in our last webinar. The tails of those distributions actually point to the places that leverage flow. If you don't understand those control points and you don't protect them with buffers, then you don't account for supply variation. Demand-driven scheduling accounts for supply variation and continuity, and it plans for it. It is able to dampen it and block it, giving you a realistic schedule and excellent on-time delivery. The solution, Demand-Driven Adaptive Enterprise, is a solution for the complex problems that manufacturing and operations and engineering and research development and all supply chains face today. A management and operational system for complex and volatile manufacturers and their supply chains follows some very specific prerequisites. DDAE is the only thing that encompasses all 4 prerequisites to achieve a flow-based strategy. The very first is understanding relevant ranges. We spent a lot of time in the last webinar talking about that. The second is to implement a flow-based operating model following the rules for a complex adaptive system. The third is to implement flow-based metrics. We call those smart metrics, and you can read about them in demand-driven performance using smart metrics. And the last thing is the ability to keep your model up to speed. Everything changes, life changes, product mix change, resources are added, we have improvements. If you don't reconcile the difference between what you plan to have happen and what actually happens in a constant weekly manner, then your model becomes obsolete, and it adds variation into your world. So reconciliation of that relevant ranges is what tactical DD&OP is all about. So when you look at a demand-driven adaptive enterprise schema, we're really focusing on, I'm going to grab my laser pointer, these relevant ranges. This is tactical, execution time frame. This is strategic. DD&OP reconciles and keeps this model fresh. The demand-driven operating model lives on the tactical side. What we expect is to have a strategic direction that gives us plan parameters. Those plan parameters actually become the model and part parameters. We're going to go deep diving into DDOM in a few minutes. Once I have the model, then I can issue a realistic plan and a realistic schedule for materials, information, and resources. The variance analysis that is talking about down here is the reconciliation between what we plan to have happen and what actually happens. The ability to capture reason codes at the source of variation is what makes this system so powerful. That feedback loop goes back into demand model projections and goes back into strategic direction. Where do we invest in either people, resources, or capacity plan? Model parameter management is part of your system, and it's the responsibility of top management to make sure that it happens. DDAE recognizes the difference in relevant ranges, and there isn't any other system that makes that distinction. If you don't understand when costs change, then you don't understand how to control costs. When you don't understand that flow is the driver of all revenue and cost, then you don't understand your business. So DD&OP is the constant system integration point bridging these ranges, and it's going to be the source and topic of our next webinar. So DD&OP tunes the demand-driven operating model. Think of it this way. I'm adjusting those model part parameters, and then I am driving flow and execution. If you don't have the right rules, you haven't built the system. People behave according to their metrics and the rules you give them to operate. Those rules that you give them to operate better match the metrics, or people can't behave in a manner that makes sense. If you look at the demand-driven adaptive enterprise level and focus, which we did last week, very quickly, what we're showing is how each level of DDAE attacks and solves one of those variation systems. So down here we're talking about cost and efficiency metric. That's the source of a tremendous amount of conflict. I also have forecast distortion, and I have schedule nervousness. As I walk up the layers, each one of these is tackled. This is DDOM. If you don't have this in place, you haven't ended this, and you certainly can't move into demand-driven S&OP. So a demand-driven operating model is the foundation of DDAE. It's visibility to relevant information that determines an organization's ability to adapt and improve flow. You can't manage what you can't see. I want to take a minute and talk about thoughtware, because thoughtware is the basic core of how all of this came into being. It's the design of a demand-driven operating model requires system thinking, thoughtware. An organization has to be able to observe, identify, and resolve distortion to relevant information and materials at a system level. Doing it at a resource level doesn't solve anything. If you can't see how the system interacts and where the source of the issues are, you can never solve them because you're solving at a symptom level. Software's job is to provide a framework of visibility to relevant information to sustain and improve DDOM. That means that software has to be built on the right rules. The better an organization can see flow, the more adaptable and sustainable the organization is. And ensuring and maintaining a framework for those 4 prerequisites we already discussed for relevant information has to be the primary job of senior management. It's senior management's job to be certain that they are aligning the organization with the right information and the right metrics. So the right rules for complex adaptive systems are all about designing for flow visibility. If I have flow visibility, I have relevant information. And in the past, we've talked about everybody's understand that there is a very solid equation that connects flow to ROI. And what's been missing that the demand-driven operating model has brought as a solution to manufacturing and supply chains is that lack of visibility to relevant information. So if I use the demand-driven operating model and I use the complex adaptive system rules, I actually can take those rules and build them into an entire system of visibility and management. And when you look at it, I've broken those into where it fits. So we're going to spend a little bit of time talking about thoughtware, and then today we're really going to focus on demand-driven scheduling and execution, DBR+. And next week we're going to be looking at how do we take that and drive smart metrics to give you a continuous improvement through tactical reconciliation. How do we link the entire environment up strategically, tactically, and in an execution time frame? So this should be familiar to anybody who's either read the book or been out on DDI. This is actually a client of mine from mid-2000s. But what you're seeing here is everybody understands that DDMRP puts in a stock buffer and it decouples. The whole point of decoupling is to make those short lead times. Those short lead times actually give us the ability to break variation between time periods that stops both supply continuity variation and demand continuity variation. Okay? Drum buffer rope where we differ from drum buffer rope, what we discovered in doing demand-driven execution and scheduling is we don't focus just on the bottleneck. A drum is simply a special point that is a control point. It's a special case that we use to schedule from. What we're really looking for is control points where we gain visibility and we actually control entry and exit into the system. Time buffers and capacity buffers are how we protect those control points, those points that keep us on site, on track, on spec, on quantity. And we do that by a combination of stored time. We're going to talk about that. There are three types of buffers that dampen variation and protect those strategic control points. The very first one you're fairly used to, you see it as stock and decoupling points. The second is time, and the third is capacity. The point I want to make is that all of these buffers are strategically placed and sized. They're also all stored time. Because they are all stored time, they're interchangeable and they're interdependent. And if you don't understand that interdependence and interchangeability, we will get very clear on that in the next webinar. In the last webinar, I showed you very solidly why a change in the green zone actually creates a very big change in your schedule and in your quantities. So if I am putting more onto the floor and increasing my WIP, I'm increasing my R+ lead time or my reliable time to replenish. That means I'm going to have to increase my stock buffers. All of these things work together, and that needs to be understood. Buffers are the heart of smart metrics, and buffers provide visibility to where and how much we have over or under invested. So let's take a quick look and just understand how we place these control points. A realistic schedule assumes continuity, supply continuity variation, and it accounts for it by the very first thing it does is it's looking for a place to schedule everything from. Because I have a convergent point, and because I know that this actually takes 30 minutes instead of 5, 10, 5, 10, I know that this is the most constrained resource, and it also is in a great place to control my entire environment. That's why it's chosen to be a drum. Drums are finitely scheduled. That means I have a realistic schedule. I am pulling and pacing the rate of all resources that feed that drum. The second thing I'm doing is I'm protecting all the control points. Why? I take all the variation out, all the queue time, all the wait time. People today pad advanced planning systems because they know they're going to be wrong. So there's a lot of padding in there. We take all that padding out and we put it someplace where it does us some good and we can actually control and see it. So when I protect with a time buffer, you can imagine variation building from all of the continuous resource feeding. Work orders come in and they come in somewhere in that buffer. As long as I hit the buffer, I'm not late. And that's really what we're doing, is we're protecting these. If the drums and the control points are on schedule to start, then the whole system is on schedule. Protecting with capacity is what allows drum buffers, time buffers, to be actually smaller. the more capacity I have, the less variation I will have that I can't recover from. And that means I can have less time in my time buffers. The whole point is not to misuse this capacity. One of the problems with lean is we lean out extra capacity, sprint capacity, and that sprint capacity is critical to be able to deal with variation that's inherent in manufacturing. We use the 10-zone buffer board, and what this allows us to do is show the top. This is what's coming at us. When it does come in and is received, it's time-stamped, and depending on what zone it occurs in, your reason code can be forced. If I come in early, I need a reason code. If I come in red or late, I want to know why. This gives me the ability to Pareto those tails and understand too much, too little, too early, too late. The market strategy is built into the demand-driven design, and this is where thought work comes in. When I have a client that tells me they need a 1-week lead time to be at the top of their market, then I do not need to put in a stock buffer at the end. And in fact, what I have to do is make certain that I have enough capacity to be able to get from 1 week from these stored buffers to the customer. So an assemble to order inside a strategic market lead time of 1 week is designed in. And then you know what the model parameters have to be to hit it. If you can't hit it, you're going to have to look at some investment. What we're looking here is that visibility. This visibility ties the entire system together. These are the source of smart metrics to execute, and when you trend them, they are the source of smart metrics for tactical reconciliation and decisions on where and when to invest. This is simply another picture. This is next day shipment. Notice that we have built distribution centers from central warehouses, and everything is make to stock. This is an example of a mixed assemble to order and make to stock spares. Very long-lived heavy equipment that's expensive. If you have an airplane down, a mine down, a ship down, you want to be able to ship your spares in 1 day because that makes you more valuable to your customer. So notice that we have spares components that are also used to make the product, and we've stocked them at the end. Those subcomponents are also buy parts. When I get a order, I capacity test it against the drum. I make a promise date. I flow through and I ship to my customer based on a promise that I can actually hit. When I get a spares order, I ship directly. When I know that I need to rebuild those spares because I've entered that yellow zone in my stock, I reschedule. And this just trickles all the way back. And what I'm showing you is every single part of this design was done with good thinking, good rules, and good thought work. Okay. This is simply an engineering to order, and what I really want you to see here is that we've decoupled with time because materials and information have to flow. Sometimes I have information that's more important than materials before I get to my planning. I need that drawing before I can even make that order. So demand-driven operating model deep dive. Let's talk about, now that we've thought about the thoughtware and we have the design and we know what that's going to be, we actually are looking at what DDMRP does. It acts as a supply generation. It's the heart of supply generation. Over here we have demand-driven scheduling. Its strategically placed control points allow us to finitely schedule to the constraint resource or the scarce resource, and those buffer status priorities and keep us on schedule with execution. Those priorities are fed directly from DDMRP and are updated every time that it's run. So I have a fresh look at what's truly important. Demand-driven scheduling and execution is following the changing priority of what's already on the floor. We never reschedule. We only change the priority of what's on the floor if we're in a serious level that says, DDMRP says, we are going to stock out or we're going to have a problem. Okay. Model parameters feed both of these. Actual demand goes in. DDMRP generates a make to stock or a make to order. The promise date is finitely capacity scheduled. Return to DDMRP so it knows when to expect it so that the alerts stay fresh. Work orders are released to the floor. Once they're released, they're locked into the schedule. And our job is to choke the floor or feed the floor depending on how well the floor is pulling its work through. DDMRP also feeds a priority update every time you run. Some of my clients, it's once a day. Sometimes it's several times a day. That priority update tells us if anything's changed and we're in trouble. Tactical reconciliation means that those smart flow metrics are captured and then they're understood, reconciled, and fed back into the model. And that's how it all works. So what I want you to see is, let's take a deep dive at what these model parameters are. If I look at DDMRP, those model parameters blow down to here. I suggest if you don't know this, go out into DDI. These are written up in all of the DDMRP material. And basically, it acts as a master schedule. If you don't have each of these DDMRP components, then you do not have a DDMRP system. Making certain that each of these are up to speed, reconciled, and reviewed weekly and monthly needs to be part of the S&OP team. We call it a modeling team. DDMRP buffer compliance criteria is known. If you don't have it, it's not DDMRP. Now let's spend some time about what's going on with drum buffer rope or demand-driven scheduling. These are the master settings and the model parameters. Manufacturing orders come in from DDMRP, and then using these settings, we have these components. You're going to see these components explained during the demo, but they need to be here. So a DDI demand-driven modeling and scheduling compliance criteria is out on their website. You can go look at it. If you're going to be compliant, you have to hit all of these things for modeling and scheduling. We're going to show you them in our demo database. If these tests aren't met, it's not demand-driven. The important part of executing the model is to have visible, relevant information about the state of your system. That's gained by looking at the real-time state of the buffers. Too little, too late, too much, too early. Demand-Driven Institute clearly defines the demand-driven execution compliance criteria. We'll show you that in the modeling session, the demo that's coming up. But you can see that all four of these are met. And if you don't have them, then you are not meeting demand-driven execution. And you can't get to smart metrics, which means you cannot get to DDS&OP. And with that, I'm going to turn it over to Kirk Black and let him take us through the demo for DBR Plus. And you'll understand what you've seen previously is the minimum criteria. What you'll see in our demo is why we call it DBR Plus.
Hello, everyone. Good to connect with some of you again, and others I haven't met yet. So what I'm going to do first is we're going to go through DBR Plus relatively quickly. And as Debra pointed out, the modeling process in DBR Plus is extremely flexible. We have done this for engineer to order, make to stock, assemble to order, and all combinations of those things in DBR. But the basic modeling starts with the resources that we have. And these are the work centers and everything. This is a very small test demonstration database that we created. There's all kinds of properties that are here. Each resource has a calendar, and there's different options that we can have for each resource so we can make certain things behave the way we want in execution for each resource. But that's kind of the foundation of the model. And we also have three different choices for resources. We have what's called a regular resource. We then have a constraint, and I think most of you are familiar with that. The other one we have is what's called a buffered resource. This is a resource that does not have finite capacity scheduling, but we do have a time buffer in front of it, okay? And then the next thing I want to show is I want to show the parts, and there's other tables that are in DBR. So again, this is a very small database. We've only got just 12 parts or something like that. And each part has what's called a product family in it. And the purpose of the product families is so that we can set different buffer sizes for the drums and the final buffers based upon the amount of variation in that particular routing, so that you know that we want to be able to protect the drum schedule. So we want to make certain that we have enough buffer time there, and we also want to protect the completion dates so that we ship on time, so we can have variable buffers there. And this is, again, a very simple database. There's varying buffer sizes you can see just for the example. And each part is linked to a certain product family based on the known variation that we have for those parts. So the first thing I want to demonstrate here is we're going to take the finite capacity scheduling, and we're going to do that. And we have this resource C1 that we have, and I've set it to a regular resource, which means that we expect it possibly to overschedule from time to time. Now I'm going to run the scheduler here, and what I want to show is I'm going to sort on the on-time column, and what you're looking at here is the scheduler's workbench, okay? And there's a variety of information in this for the scheduler. But what I want to show is the DBR will schedule some work orders early, and it will schedule some work orders late, and it will schedule work orders on time. Okay, so there's a variety of things here. So look here, and we have 7 work orders that are late in this particular setting. And if I save this here, then we go out, and if we look at the resource load graph for this resource C1, which is now set as a resource, you can see that we have some overloading. And this yellow means that we are over the available capacity for the day. This red line means this is the available capacity. And this also shows how sales orders typically will come into a plant. Some days we're going to be asked to do quite a bit. Other days there won't be anything. And yet other days and combinations of days we're going to be asked to do much more than we can actually do. So this is not an executable schedule. If I go in though and I set this resource to a constraint and then rerun the scheduler, one predicted effect is we're going to get a lot more late work, and you can see that just showed up here, okay? But what this means is we're being asked to do more than we can actually complete in the time frame we're being asked to do it. So this is a reality of what happens. So if I save this here, and then we go back out and look at the resource load graph for this and refresh this, then you can see now we have an executable schedule. No day where we have a drum or a constraint selected is scheduled over what its available capacity is, okay? So that talks about finite capacity scheduling and what it looks like in DBR Plus. The next thing I want to show is how DBR Plus talks to R Plus, and that's in this menu here called Replenishment Plus. And there is, I won't go in and explain all the details, but there's a setup involved, and there's an access token where DBR Plus does a handshake with R Plus, and it goes out and pulls certain information. And then here's the settings that we have. Now in DBR, there are many priorities available. We've just chosen to use only the first 14. And the lower number means it's a higher priority. So a priority 3 has a higher priority than a priority 5. And this is important because the way DBR Plus schedules, it first schedules to meet the due date, if at all possible. If not, then it will look to the priority and schedule the highest priorities first and get them first, the first place on the drum, in the drum schedule, okay? So when we run the scheduler, okay, and we'll leave this as this C1 as a constraint, and I'll actually filter only so we can focus in on what's happening at this constraint, okay? And you can see we have a variety of priorities, okay? Now, one thing I want to point out, and I'm going to sort there, we also have the ability in DBR Plus to override priorities. And you can see I made this one a priority 2, which is a higher priority than a priority 3. And I also chose to freeze this priority so that it would not change. Now, we won't go into all the reasons why you would want to freeze a priority or not freeze a priority, but the high level is we would want to change the priority so that this work order gets pulled ahead in the schedule ahead of other priorities if there is a capacity constraint, which you can tell we have a capacity constraint here. The reason we'd want to freeze a priority is because we want to make sure that priority holds all the way through execution so that the shop floor can also work to that priority, okay? So what happens in the scheduling phase then, oh, the other point I want to make about the model, when you're modeling anything, particularly with DBR Plus, you need to make the model reflect your reality today, not what you want parts, how you want parts to be built, but how they are actually built. Then you change the model as your processes change and you update. If you set up your model to reflect how you want to do things, that's basically an unexecutable schedule is what you're going to be creating, and things just won't be working or flowing well. You're going to get a lot of late and a lot of early, and it's just not right to do. You need to build your model how you build parts today, okay? So during the scheduling phase, okay, the first thing we do is run the scheduler. And one of the very first things the scheduler needs to do is understand the state of the DBR system. We have a tool in DBR Plus called the System Load Graph. And what this shows is the loading and the condition of every resource in the plant. And I selected backlog here. And this is set to a 1-week time frame, okay? So if I refresh this, now we can see which resources have backlog, where they're behind in the schedule, and this is done on purpose for this demonstration. And we can also see some resources that are potentially overloaded and that we have got to pay attention to so that we don't release more than what they can do. We can also show only the constraints in the system and what theirs are, or we can show other constraints. So on this particular constraint, because we have backlog, we are also potentially overloaded if we release all of that work, okay? So by looking at this, and if the scheduler needs to, they can also go to the resource load graph to get more details. We saw on the one, there was a resource R12. R12 was overloaded, and it looks like it's severely overloaded. It's okay for today and tomorrow and through Monday, but then coming up next Tuesday, the following week, and the week after that, it's severely overloaded. So we have to pay attention to what we release to R12, okay? So now that the scheduler knows the condition of the system and the state of the system, the scheduler begins what we call schedule massage. And the first point I want to make is there's no perfect schedule that is going to be created, okay? We have the buffers, there's variability. The objective of scheduling is to create an executable schedule that is synchronized to the market. And we use the priorities that when we connect to R Plus to do that market synchronization to tell us about our stock buffers and our make to order work orders, okay? So the scheduler then will sort on the on time column, okay, and see which orders are late and what needs to happen with those. The scheduler will sort on the priority column, and there are multiple column sorts available. And when everything is done, the scheduler will sort on the planned release date column, and then DBR Plus says these are the days to release. We also allow a release horizon and not just release today. So in most companies, it's either 2 or 3 days. So if this is to release tomorrow, this would be 2 days. So these 3 orders here, we would go ahead and release. And the assumption here is that we have done all the schedule manipulation and put these orders in the right sequence the way we want them. To do that in Schedule Massage, there's a variety of things that we can do. Again, one thing we can do is temporarily override a priority like was done here. We can also go in and we can split a work order. So notice this one is 2 days late. If I go in and split this work order here, and I'll just split it into 2, and then it creates an additional work order, and then I hit the schedule button again. So what we have now is here's that work order with an A suffix. It's this work order with the A suffix. So now I've got 7 pieces that are going to be 2 days late, but I've actually got 7 pieces that are going to be a day early now, okay? And so that's what splitting can do for you, okay? Other things you can do is you can go in and you can select alternate routings if there's an alternate routing available. And let me see right here. So in this order here, I have an alternate available that I can pick here, and this would help if we're overloaded in a particular area. We want to be able to have routings that can offload to areas that are not so heavily loaded. And we can also do expediting of orders from this screen. As an example, I can take this order here and I can choose to expedite it, and we have 3 levels of expedite, but in this case I will just choose the drop buffer expedite, and it made it 1 day early by dropping the buffers. Expediting also gives a work order a higher priority in the schedule. So it schedules by these priorities, but if there's any expedites, which you can see here, it says drop buffer, it gives it a higher priority, okay? So when scheduling is done, okay, again, we'll sort on the planned release date, and I will undo my filter and look at all the products, including free product, and I will select all the orders within the release horizon that should be released today, okay? And so it's as simple as selecting those and releasing and then saving it, okay? So when I save it, now this pushes out these work orders out to the web interface or the user interface. So these graphs now have been updated, and if I go back to our resource load graph for C1 and we look at that, now you can see there's more work that has been released out here, okay? So at this point, the job of scheduling is done. It is now up to execution, okay? And remember, in execution with DBR, this is about relevant information for the time frame, and because DBR Plus is real time, this is about the state of your system at this point in time. What is happening right now? So we can see at this resource, we have 15 hours of backlog. If I want to see how far back in time that goes, it goes back 2 days, okay? There is a legend here that shows what each of these color codes mean, okay? We won't go into that today. Also in DBR, there is a resource schedule, we call it, or this is the dispatch list, as some of you know it. And the way we work this is we show people the expedites always come to the top of the list here. There's different colors and things. We have 3 kinds of notes in DBR. There's pink notes that are production notes that talks about problems. There's yellow notes that are work in process notes that the scheduler generally enters. In this case, they said we're not going to have material. And then we have transaction notes, and that's the blue. And this is any notes that whoever entered a transaction, they would enter. We come in and we have them do the expedites first. Then we have them sort on the priority column, and we then do work from the top down up to priorities 2, 3, 4, and any 5s, if any. You can see here they stop at priorities 4. The reason we want to get those highest priorities out first is so that we synchronize to the market and protect our service levels first. Then after all of these 2s, 3s, and 4s are done, we come back and we sort again by start date. And this order is sorted by start date. So we would come back then and do this priority 7 order, and then this priority 11 order would be after that in this case. The other big thing, as you know, there's time buffers in DBR, and the buffer boards show the status of each of the orders that has been released. We've got one order that's released here. I'm going to quickly go through this. I want to do a transaction and receive this order so you can see what DBR Plus does with the reason code. So I'm going to receive it. We know that it's in the late zone. It tells us it's in the late zone. I have to pick a reason. If I try to select this, it says you must enter a value for the reason code. So we force those to enter. I'm going to enter manpower, and I could enter a note here about what happened, and then I update that, and now that is showing received. I've received 12 of 12. If I go back to the buffer board, then you can see now that work order has been received. And again, these are orders that are at this resource and ready to go. These are orders that are not yet at the resource, so they're coming in. So the role of the buffer manager would be here. The role of the resource manager would be down here in the receive section. Okay. So again, DBR Plus is real time. We also can filter. We have certain filters here. I just set it up. If I was a buffer, I had different buffer managers here. I could apply this, and it turns out Jennifer has nothing there. Maybe Alex does. No, he doesn't either. So I guessed wrong, or Kim. So anyway, you can say, here we go. So Mark, you know, these orders are assigned to Mark so that they can drill in on the orders that are specific to their work, okay? The great thing about DBR Plus is that when people see this, and we have a daily buffer meeting every day. It usually lasts 10 to 15 minutes where we get all the buffer managers and resource managers together, and they see this, and because this is a complex adaptive system, the people use this and they start learning and improving on their own because it is so visible and so easy to read and interpret. The last thing I'm going to mention before we're done is we have a reporting suite, and all of these on-time release, on-time to start, on-time to buffer, the reason code report, they're very easy to generate. I can do a reason code report, and I'll just go back a couple of days and just show what it is, and it comes out in Excel, and it comes out in a flat file, so you can quickly take this information and develop your reason code trending and your reason code focus reports, okay? All of these reports here are basically historical reports, and these reports are all used to feed to the DDS&OP, the tactical range process, and the DDS&OP team, so that they can start to see, are we going in the right direction? Are we going in the right direction fast enough? And all those things. So I am about out of time, and so I will stop there, and if we have any questions or any additional comments, we'll open.
So Sean, why don't you go back to making me the presenter? We'll just go to the questions slide. And this is simply showing you the metrics. These are what you're attempting to show. You want reliability, stability, and velocity. All of those reason codes and all of those buffer Pareto analysis are telling you exactly what it is, how you did. Okay. The message is really critical that you send with the metric, and what you're seeing is the message that each one of these metrics sends. And I'm just going to go to the end and say, do we have any questions? And that was a lot to cram in your brain. And hopefully we'll see you next time where we're talking about how to use this information from these reason codes and do some tactical reconciliation with real case studies. So Sean, do we have any questions? I guess not. Thank you so much for your time today. Hey, Kirk, thanks. Kirk's down in Bogota working with a very large, I guess they make cloth. I guess that's the best way. Yeah.
Fabric. Yeah,
fabrics.
Yes. Yep.
Yes. So, all right. Thank you so much.